we are dealing with three kind of equivalence. The first one is the structural equivalence, the second one is the automorphic equivalence, and the third one is a regular equivalence. Now what we have in structural equivalence, here we are going to relate two modules or two persons based on their equivalence properties. Now we are dealing with social network analysis. So just consider the example of the Facebook. There are some people who belongs to the same family. There are some people who belongs to same city, and there are some people who belongs to the same country. Okay, so this is the example for the structural equivalence, automorphic equivalence, and the regular equivalence. Now, if you consider all the M.Sc students from Ratnagiri, and if you consider all the MS students from Ratnagiri, and the structural equivalence means a family. If you have something common as a structure, it is referred as an equivalence. Means you can say that you have a common genetical structure between your family. So you can say that this is different definition for the structural equivalence. Another example is the set of all laptops. They have the structural equivalence. They have something as a structure, therefore it is referred as a structural equivalence. In automorphic equivalence, if they belongs to the same title or they belongs to the same label, it is referred as the automorphic equivalence. Now for example, there are MSc students, and the MSc students are under Master of Science category. So you can say that all the MSc students come under the one category, that is the PG students. Even MS students also come under the same category, that is a PG student. So they both are under one label, that is a PG. That is referred as a automorphic equivalence. Now, if you deal with only MSc, it is also example of automorphic equivalence because the label is MSc. That means that everything defined or everything depends on the label. If the label is MSc, you are supposed to consider only MSc students. If the label is PG, you are supposed to consider the MSc as well as MS student. It will not cover the TYBSc or TYBA. If you want to consider only just science students, so it will cover FYBSc, SYBSc, and the TYBSc as well as MSc students. If you want to cover the arts, it will come as a FYBA, TYBA, SYBA, and MA. Now the regular equivalence also possesses with the same property, but it does not depend on only the label. It also depends on the another properties also. So it is defined as a regular equivalence. So we are supposed to define three kinds of equivalence, that is a structural equivalence, automorphic equivalence, and the regular equivalence. Now let's start coding. Here we are supposed to input a graph, and we are supposed to use this ages file. That is a dataset 2 media user example ages files, or you can use dataset 1 media example ages file. You're supposed to use the ages file because you want to show the network, you want to show the connectivity. So for that purpose, you want to display the equivalence relation. So you are supposed to import the SNA library. So the first statement is a library SNA. I will execute that statement. Okay, if the SNA is not available, you are supposed to do install.packages SNA. So it will install that particular package and it will allow you to use that package. So this is the first package that you are going to use. Second is the common package because you are going to display the graph. Therefore, you are supposed to use iGraph. That is a library iGraph. Now you are supposed to display the links, and you are supposed to retrieve the links. The links are nothing but the relation. Therefore, you are supposed to retrieve the relation. Therefore, you are supposed to read this CSV file. Now, I have stored that CSV file to E colon. So simply links2 is equal to read.csv E colon path header true row names equal to 1. Now I will execute these two statements. Fine. Now the links are ready. Okay. Now I want to display the equivalence relation. I want to display it according to the cluster. So how can I display? So the display according to the cluster, I can do EQ is equal to equivalence.cluster links. So now we are going to do only regular clustering. Okay, later on we will going for the block model. So equivalence is equal to equivalence dot cluster into the bracket links to. So it will execute, and now you're supposed to plot that graph. So it will come accordingly. Okay, so it will come accordingly. This is a dendrogram. This is the cluster dendrogram. You are going to define the cluster. Fine. Now just see here. This is the height of the tree. Okay, and it is a, you do not have any relation with the height and this one. This is related to this tree, and this is the actual your data. Now just see here. You can say that 15 is also related with 7 under this platform. Okay, even you can say that the 15 is also related with 8 under this platform. So every element is related to each other. May not be they directly related, but they are related to each other. Likewise, 14 and 15 are related to each other. Same thing, 12 and 13 is also related to each other, and the same thing you can work. Okay, so in this way you are going to display the cluster. Now we want to display the block model. The block model is going to give the exact overview of actual equivalence. So for that purpose, we are going to calculate the distance. Later on, you can plot that distance. So this is the actual centroid. You can say that they are the centroid. Means, for example, whatever the data we have, we are going to minimize that data. We are going to finding out the common factors, and these are the common factors. Later on, you can display this into the block model also, and you can plot this graph. This is the block model. Okay. Now, whatever the graph this is, just see here. This is the graph, and this is your block model. Now just see here, though you have the points, you are collecting now the surrounding points also. Therefore, it is given by that particular black head. Okay, it is also collecting. Means, for example, if the point is 26, it is going to collect 24 as well as 25 as well as 27 as well as 28. So you are going to collect all these points together. Therefore, it is displayed with the black head, or is displayed with the black label. So this is all about for the practical number 6. I will repeat all the things again. We are supposed to write, or we are supposed to display the structural equivalence, automorphic equivalence, and the regular equivalence from the network. For that purpose, the structural equivalence means if you have something as a structural similarity, automorphic if you are belonging to the same label, and according to the both belonging to the same label, belonging to the structure, even with some other properties also, it is defined as a regular equivalence. Now here you are going to import the SNA library, as well as you are going to import the iGraph library. Now you need to import the CSV file. It will be given into the question paper, and you are supposed to take according to that actual question. Then you are going to display the clusters, and you are going to plot these clusters. So the clusters are displayed according to this. This is a dendrogram, and you're going to display the dendrogram. You're going to display the relations between two modules or two variables based on that dendrogram. Then you need to calculate the distance. So you need to find out the clusters. So the clusters are find out according to this formula. G.SE is links to. So these are the clusters, and these are the actual values. These are displayed by the block model, and you can plot the block model as well, so you can get the output. Okay, so this is all about the practical number 6. If you have any query, please ask.